Hello students, welcome back. Now let's continue with remainder theorem. We will be solving certain numericals today. But so these are based on remainder theorem. To put down remainder theorem into simple words, when the zero of the divisor is substituted in the variable of polynomial, we get the remainder. Okay, so when the zero, now here is your question. Find the remainder when this polynomial is divided by this linear polynomial. So this is the divisor, x minus 1 is the divisor. Now when the zero of the divisor, 0 of x minus 1 is going to be x minus 1 is equal to 0, which is 1. So when the zero of the divisor, which is 1 in this case, is substituted in the variable of the polynomial, we get the remainder. So I am going to substitute 1 in this expression in place of x. Okay. So first of all, here solved example 9, let's solve it. First of all, I am going to define my polynomials, px as x4 plus x cube minus 2x square plus x plus 1. I'll just write this a little more neat. Okay. Also in remainder theorem, it is not really important to arrange your polynomial in descending order of the exponent. So that is another plus point. Plus it is a shortcut method. And let's say gx is my divisor, which is equal to x minus 1. Okay. Now solution, 0 of x minus 1 is x minus 1 equal to 0. I'm just solving is 1. How? X minus 1 is equal to 0 and therefore x is equal to 1. So 0 of x minus 1 is 1. Now I'm going to substitute 1 in this polynomial equation or expression. It's going to be 1 raised to the power of 4 plus 1 raised to the power of 3 minus 2 into 1 raised to the power of 2 plus 1 plus 1, right? So 1 raised to anything raised to the power of 1 raised to the power of anything gives you 1. So 1 plus 1 minus 2 into 1 is going to give me 2 plus 1 plus 1. This is going to give you 2 minus 2 plus 2. So you see that 2 and minus 2 cancel out and you get your remainder as 2. So your remainder is 2. Now let's go ahead and solve the other sum. Let me quickly erase the board for you. Okay. Check whether the polynomial qt given by 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. Now in order for 2t plus 1 to be a multiple of this polynomial qt, it has to divide it completely. That means the remainder should be 0. So how are we supposed to find the remainder? I am going to find the 0 of 2t plus 1. So solution for exercise 9, sorry, example 10, 0 of 2t plus 1 can be found as follows. 2t plus 1 is equal to 0, right? Therefore 2t is equal to minus 1. Therefore t is equal to minus 1 upon 2. So 0 of 2t plus 1 is minus 1 upon 2. Now I am going to go ahead and substitute minus 1 upon 2 into qt. So qt, let me just write the polynomial first. Qt is equal to 4t cube plus 4t square minus t minus 1, right? So substituting t is equal to minus 1 upon 2 into qt, you get q of minus half. Notice that q of minus half is going to give you the remainder. So, if the remainder will be 0, 2t plus 1 is going to be the multiple of, I am sorry, it gives me the multiple of 2t plus 1. So, in that case 2t plus 1 will be the factor of qt, which means that qt will be a multiple of 2t plus 1. So, 4 into minus half the whole cube plus 4 into minus half the whole square minus into minus half minus 1. So, 4 minus cube of minus is going to give me minus, 1 cube is 1 and 2 cube is 8 plus 4 minus 1 square, minus square is going to give you positive. So, 1 and 2 2s are 4, 2 square is 4, right. Minus into minus is going to give me plus, so plus half minus 1. 4 1s are 4, 4 2s are 8, 4 1s are 4, 4 1s are 4. So, I am left with minus half plus 1 plus half minus 1, right. So, minus half plus half cancels out, plus 1 and minus 1 get cancels out. So, I get my value as 0. So, q of minus half is 0, which means that qt divides, I am sorry, 2t plus 1 divides qt completely because the remainder is 0. Therefore, qt is a multiple of 2t plus 1. So, here we are done with the solved examples for remainder theorem. We will go ahead and solve the exercise using the long division method as well as the remainder theorem. I am just erasing this remainder theorem for now. So, what I will do is solve the same sum using remainder theorem on one side and long division method on the other side of the board. This is exercise 2.3 section 1. It says find the remainder when a polynomial px given by x cube plus 3x square plus 3x plus 1 is divided by 1. X plus 1, 2, x minus half, 3, x, 4, x plus pi, and finally 5 plus 2x, right. So, I have my polynomial x cube plus 3x square plus x plus 1. Now, while solving the sum using the remainder theorem, you do not really need to arrange the polynomial in descending order of the exponents. But when you are doing it by the long division method, it is very important. So, let us just check whether it is arranged properly. So, you have x raised to the power of 3, then x raised to the power of 2, then x raised to the power of 1 and x raised to the power of 0. 1 into x raised to the power of 0 gives you 1. All these are arranged. Right. Fifth one is not arranged. So, I am just going to rewrite it as 2x plus 5, because you have x raised to the power of 1 and now 5x raised to the power of 0. So, first let us solve using the remainder theorem the first sum. So, my px, my 0 of x plus 1 is minus 1, correct? How? X plus 1 is equal to 0, therefore, x is equal to minus 1. Now substituting the value of x is equal to minus 1 in the polynomial equation, we will get the remainder. So p minus 1 is going to give me minus 1 the whole cube plus 3 into minus 1 the whole square. I am just erasing this for now, plus 3 into minus 1 plus 1, right? So this is going to be equal to minus 1 plus 3 into 1 minus 3 plus 1, right? So this is minus 1 plus 3 minus 3 plus 1. So everything is cancelling, plus 1 minus 1 plus 1 plus 3 minus 3. So p of minus 1 is equal to 0. So p of minus 1 is equal to 0, therefore the remainder is 0. Correct? Now let's solve this using the long division method, wherein px is going to be my dividend and x plus 1 is going to be my divisor. Then we will compare whether the results are the same. So I have x cube plus 3x square plus 3x plus 1, and I divided by x plus 1. X plus 1 into what is going to give me x cube. Now, so x plus 1 into x square. Let's get into the habit of doing this while we are doing the sum itself, instead of going ahead and doing the rough working. If you still have any difficulties, whatever I write here, you can multiply it with x plus 1, and then you will be able to get the answers and you can substitute it accordingly. So x plus 1 into x square is going to give me x cube plus x square, right? X square into x, x cube, x square into 1 gives me x square, and the sign is plus. This is minus and this is minus. Plus x cube minus x cube cancels out. 3x square minus x square gives me 2x square, right? Now I am going to go ahead and bring down 3x. So plus 3x. Why plus? Because there is the plus sign over here. So x plus 1 into what is going to give me 2x square as my first term. X plus 1 plus 2x. So see, 2x into x is going to give me 2x square as the first term. I need not worry what comes later. Okay. So 2x square plus 2x into 1 is going to give me 2x, right? Subtract, subtract, cancels out. 3x minus 2x is x or 1x, and I get down 1. X plus 1. X plus 1 into what gives me x plus 1? Into 1 gives me x plus 1. So my remainder is 0. So in both my cases, whether you are solving by the remainder theorem or by the long division method, you are getting the same remainder. So you are verified that your answer is correct. Okay. Now I am going to go and solve the second sum. It's actually the first sum itself, but the sub question. Now let's see for the divisor as x minus 1 using remainder theorem. 0 of x minus 1 upon 2 is what? Half. How? X minus half is equal to 0, therefore x is equal to half, right? So I am going to substitute the value of x as half into this polynomial. So p of half gives me half cube plus 3 into half square plus 3 into half plus 1, right? So this becomes 1 upon 8 plus 3 into 1 upon 4 plus 3 upon 2 plus 1. Now I do not have much space left here, so I am just going to continue to the other side of the blackboard. So this becomes 1 upon 8 plus 3 upon 4 plus 3 upon 2 plus 1, right? Now this looks difficult, but it's not very difficult. What you have to do is go ahead and take the LCM. 1 is nothing but 1 upon 1. So taking LCM of 8, 4, 2 and 1, 8, 4, 2 and 1. 2 4s are 8, 2 2s are 4, 2 1s are 2, 1. 2 2s are 4, 2 1s are 2, 1. 2 1s are. So LCM is 2 into 2 into 2, which is equal to 8. Okay. So 1 upon 8 into 1 into 1 plus 3. We need to equate the denominator. We need a common denominator. So the common denominator, we plan to make it 8 because 8 is the LCM. So for whatever you multiply the denominator in order to get 8, we are going to use the same value to multiply with the numerator. So 4 into 2 is going to give me 8, right? So I am going to multiply 3 with 2 as well, plus 3 upon 2 into 2 4s are 8, right? So 3 into 4 plus 1 upon 1, 8s are and into 8s are. So this becomes equal to 1 upon 8 plus 6 upon 8 plus 12 upon 8 plus 8 upon 8, right? So now since we have a common denominator, I'll take 8 as the common denominator. Now you've been given 1 upon 8 plus 6 upon 8 plus 12 upon 8 plus 8 upon 8. That does not mean you're going to add the numerator separately and the denominator separately. You're going to take the base common, you will only add the numerators, okay. So 1 plus 6 plus 12 plus 8 gives me 12 plus 8 is 20, 20 plus 6 is 26 plus 1, 27 upon 8. So here my remainder using the remainder theorem is 27 upon 8. I do not have much space to solve the sum using the long division method. So for now I am just going to keep a record of 27 upon 8 as the remainder, and we will compare the remainder after solving using the long division method. Okay. So for the record we have 27 upon 8 as the remainder for the second sum, right? Again using the long division method, I'll write my polynomial. Everything is arranged in descending order of the exponents. So x cube plus 3x square plus 3x plus 1. Now you have to divide it by x minus 1 upon 2. This is going to be a tricky one, so please pay careful attention. Let's see how we do it. X into what is going to give me x cube? X minus half. So into what is going to give me x cube as the first term? X square, right? So x cube minus half x square, right? So x cube minus half x square. This becomes negative, this becomes positive. This cancels out. Now 3x square plus half x square. Let us solve it here. So I am going to do the multiplication part here, and whatever calculation is needed here, I am going to do it in this part, okay. So 3x square plus half x square. The LCM, this is 3x square upon 1. So LCM of 1 and 2 is 2. So I am going to multiply this by 2 and this by 2 as well, right. So my LCM is 2, 6x square plus x square. So this becomes 7x square by 2. So x minus half into x square, oh I forgot to write it here. So x minus half into x square gives me x square minus half x square. The output here is 7x square by 2, and this is positive, sign of the greater number. and here also it's getting added. So 7x square plus 2 plus 3x. I am getting down 3x. Okay. Now x minus half into what is going to give me 7x square upon 2 as the first term. So I am just writing x minus half into what is going to give me 7x square upon 2. First of all, we are going to look for the variable term over here. So into x is going to give me x square. How about 7 upon 2? So you simply multiply by 7 upon 2, right? So 7 upon 2 x into x gives me 7 upon 2 x square, right? Now 7 upon 2 minus 1 upon 2, 7 upon 2 x into minus 1 upon 2 will give me 7 upon 2 x into minus 1 upon 2 gives me 7 ones are 7. You have x and there is a negative sign here, and 2 2s are 4. So minus 7x upon 4. Okay. So minus 7 minus 7 upon 2x gives me 7x square upon 2 minus, let me just write it here, minus 7x upon 4, right. So it gives me 7x square upon 2 minus 7x upon 4. Negative, positive, cancels out. Now adding these two terms, where do I do it? Okay, there is place, but it will get messy, so let me just erase this part for now. So 3x plus 7x upon 4. This is nothing but 3x upon 1. LCM of 1 and 4 is 4. So 4, I am going to multiply the denominator and numerator by 4. So I get 3 4s are 12x plus 7x, right. 12 plus 2 is 12 plus 7 is 19. So 19x upon 4, right. No, yeah, 19x upon 4 plus 1. Now x minus 1 upon 2 is multiplied by what is going to give me 19x upon 4. Let me do it here itself. X minus 1 upon 2, 19x upon 4 as the first term, okay, into what is giving me 19x upon 4. So we already have x, right. What we need is 19 upon 4. So I am going to just go ahead and multiply it by 19 upon 4. So 19 upon 4 into x gives me 19 upon 4x minus 19 upon 4 into minus half. So 19 upon 4 into minus half gives me 19 upon 8. So minus 19 upon 8. Okay. So into plus 19 upon 4. What is my output? 19x upon 4 minus 19 upon 8. This becomes negative, this becomes positive. Cancels out. Now 1 plus 19 upon 8. 1 is nothing but 1 upon 1. So I am going to multiply it by 8 to take the LCM. The LCM is 8. 1 into 8 gives me 8 plus 19. 19 plus 8 is 27. 27 upon 8. So I got my remainder as 27 upon 8 using the long division method. Let us compare. Fantastic. We have 27 upon 8.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.